This is a bulletproof domain object. Once successfully created, it cannot be broken. But how do we create it? Or more precisely, how do we handle cases where we cannot create such an object due to invalid input data? The common error handling pattern in most mainstream programming languages is exceptions. And an exception is exactly what we would face if we try to create this object with invalid data. But is this truly an exceptional case? Or is it something we expect might happen and should plan for? So instead of aborting the request, a better reaction certainly would be to recover and provide proper feedback to the user interface. Catching the exceptions and then providing feedback to the user interface might seem straightforward, but it opens up several issues. Which exceptions should we catch? This is often not clear from the API. How do we differentiate between truly exceptional cases and recoverable errors? Using dedicated validation exceptions might help, but still serve as a covered go-to statement, creating a second, harder to understand control flow, especially in asynchronous programming. And last but not least, throwing exceptions unnecessarily may hurt performance. So in summary, reserve exceptions for truly exceptional cases. Another quite common approach to indicate that the creation of such an object failed is to return null. But I would definitely consider this as an anti-pattern because it will lead to weird exceptions or unexpected behavior at unexpected places if the caller fails to handle the null case properly. And even if the caller handles the null case properly, it lacks detailed information on what exactly caused the object creation to fail. So from this perspective, returning null is even worse than throwing exceptions. Luckily, there's a better way, which is used extensively in functional programming, the result pattern. The basic idea is to use a dedicated result type which explicitly models the two possible outcomes, OK and error. In order to force the caller to handle both possible outcomes explicitly, we only provide access to these possible outcomes through dedicated methods which require callbacks for both cases. This approach results in more expressive code as the API now documents both the happy path and the unhappy path explicitly. This pattern also ensures that the error case does not result in a different control flow. Of course, the result type can be made generic so that it can be used in many different scenarios. And we can also add implicit cast operators to make usage of such a result type even more convenient. The result type we just created is already quite powerful, but it is still very basic. When you want to try out the result pattern in your next project, consider using one of the well-tested libraries out there. But the result pattern isn't just for handling validation errors. Imagine a software where the application logic uses a parser to read some file. How should the parser module handle invalid data? Should it throw an exception and so abort the parsing? Or should the parser skip the invalid data and return only valid data? For most applications, the better solution would again be to adapt the result pattern and let the application logic decide. Maybe an error should be logged, or maybe the operator needs to be informed, or maybe some fallback solution exists. Still not convinced? Then let me tell you that Rust, one of the only two programming languages used in the Linux kernel, does not use traditional exceptions at all. This choice clearly underlines the pattern's effectiveness and power in modern programming environments. Did I spark your interest in more functional programming concepts? If so, check out this playlist. It gives you a quick overview of F# in less than 15 minutes.